June 13, 1943. Essen, Germany. Albert Speer. The office is dim, cigarette smoke curling in the air, the sound of distant typewriters rattling like machine gun bursts through stone walls. A Luftwaffe officer lays down reconnaissance photos on Albert Speer's desk. Black and white images capture the skeletal remains of an American factory, its roof panels blown apart, gantry cranes collapsed like broken arms. Speer studies them silently, his jaw tight. The date stamped in the corner reads May 24, 1943. He nods once, satisfied. A plant like that should be offline for months. Weeks later, a second set of images arrives. Same coordinates. This time, the photos reveal something inexplicable. The factory is alive again, chimneys venting smoke, rail cars lined up on sidings, new roof sections glinting in the sun. To Speer, it looks like an industrial ghost resurrected overnight. He slams the folder shut, irritated more than impressed, muttering that either the Luftwaffe had bombed the wrong target or the Americans had defied the very physics of reconstruction. The German expectation was rooted in arithmetic. Standard calculations said a heavy machine tool plant destroyed by aerial attack required at least 90 to 120 days before production could resume at even half strength. Repair crews had to clear rubble, rerun power lines, install replacement lathes and presses, and retrain workers displaced by chaos. The Reich's own statistics, compiled by the Reichsministerium für Rüstung und Kriegsproduktion, showed that after the RAF's 1942 raid on Essen, Krupp's facilities had not reached full output again for 6 months. That was the reference frame Speer carried into every briefing. Yet what the reconnaissance revealed was a logistical anomaly. The Americans seemed able to compress months into weeks. Instead of 100 days, they were turning capacity back online in less than 30. The photographs suggested fresh electrical cabling, new gantries already lifting engines, and locomotives moving stockpiles in and out. It contradicted the German industrial playbook. Speer turned to his aides and demanded clarity. Was it a deception? Could the smoke columns have been staged? Intelligence officers shook their heads. The raw tonnage of goods appearing at Allied front lines, ammunition, tanks, spare aircraft, proved the factories were not illusions. They were running at near full tilt. For the German High Command, this was the first glimpse of a deeper reality. America's wartime industry was not just vast. It was engineered for recovery speed. They were not fighting a conventional factory system. They were fighting a machine built to rebuild itself. The night sky glows red over Dayton, Ohio. Sparks fly like molten rain as acetylene torches bite through twisted beams. The factory floor is a battlefield of its own. Workers in leather gloves and soot-streaked faces maneuver through smoke, welding arcs flashing like muzzle bursts. The air tastes of hot metal and burned insulation. The building is scarred but not silent. Even as broken girders hang overhead, machines thrum in the shadows, presses hammering steel as if refusing to surrender. What reconnaissance photos could never capture was the choreography inside. Crews worked in shifts that never stopped. As one team cleared rubble, another installed prefabricated wall panels craned in from off-site depots. Heavy trucks lined the streets outside, headlights blacked out for security, loaded with spare turbines, transformers, and power switch gear. Supplies were drawn from national stockpiles dispersed across the Midwest, a deliberate American safeguard against industrial paralysis. Every hour, parts were swapped in like fresh cartridges in a gun chamber. The numbers tell the scale. Dayton's machine tool district held over 3,200 lathes, grinders, and presses before the raids. On paper, losing 20% of that capacity should have slashed deliveries of aircraft engines for months. Yet U.S. Army records show that within 17 days, the Wright Aeronautical Engine Line had resumed 80% output. By the end of the 5th week, the plant was exceeding its pre-raid quota. The factory floor moved as if the destruction had been nothing more than a pause in rhythm. Witnesses described the tempo like a piston firing without interruption. Railroad sidings were cleared within 48 hours. Replacement equipment, pre-staged in nearby warehouses, was delivered in sealed convoys escorted by armed guards. Blueprints for plant layouts had been duplicated in Washington and mailed back by courier, ensuring no lost records slowed repair crews. To outside eyes, the speed looked almost impossible. German analysts studying the film reels noted the new steel panels gleaming where the roof had been torn away, the paint barely dry. One officer scrawled in his margin notes, "Amerikanische Fabriken stehen wieder auf wie Maschinen, nicht wie Gebäude." Translation, American factories rise again like machines, not like buildings. For the men working inside, there was no mystery. They knew the strategy was simple. Build every system with redundancy, every component with a spare. In America's war economy, a factory was not a fragile structure, but an engine with backup pistons waiting to fire when one failed. Dawn creeps over the Ohio River Valley. Freight trains grind past the factory sprawl, their iron wheels squealing against the rails. Each car carries cargo stamped with coded numbers: ball bearings, engine blocks, gear assemblies. The smell of coal smoke hangs heavy in the morning air, clinging to the brick walls of warehouses. To the casual passerby, it is only another industrial town. To the German High Command, it is the nerve center of America's war machine. The math is blunt. One ball-bearing plant alone could output 5,000 tons of bearings each month. Every Sherman tank demanded roughly 350 pounds of them. A single aircraft engine consumed more than 100 specialized bearings. Destroy that stream, and a chain reaction ripples outward, armored divisions stranded, bombers grounded, convoys delayed. The gears of war literally seize when bearings are denied. Distance magnifies the problem. From Midwestern plants to European battlefields stretched 4,000 miles of logistics arteries, river barges, railways, cargo ships, and truck convoys. Each mile depended on predictable throughput from America's industrial heart. If a single factory shut down for months, the backlog cascaded across oceans. A tank stalled in Kansas meant a platoon vulnerable in Sicily. German planners had staked hopes on this arithmetic. Disrupt one critical node, and the Americans would face bottlenecks impossible to bypass quickly. Their assumption mirrored their own industrial struggles. In the Reich, when a ball-bearing factory at Schweinfurt was damaged, production across multiple fronts faltered. Repair meant reshaping complex machine tools, a process that consumed steel, energy, and time the Reich could not spare. But the assumption overlooked American scale. Unlike Germany's concentrated production model, the United States operated a web. Multiple plants shared identical tooling, identical designs, identical training manuals. If one facility fell, another absorbed the quota. In effect, each American factory was not an isolated target, but one piston in a 12-cylinder engine. Knock one out, and the rest fired harder to cover the stroke. To German officers poring over reconnaissance, this reality was not yet clear. They still believed a bomb on Dayton or Detroit could strangle the front. What they had not understood, what the next months would prove, is that American industry had been built with redundancy as deliberate strategy. The targets mattered, yes, but not in the way Berlin imagined. The room is dim in Berlin, maps pinned with colored pins, strings stretched across the Atlantic. Luftwaffe analysts lean over intercepted shipping manifests, U-boat captains radioing tonnage sunk. Their reports claim strikes against America's supply arteries will soon starve the front lines. Code clerks type late into the night, convinced that ball-bearing plants in Ohio or engine works in Pennsylvania can be knocked out like dominoes. Across the ocean, another montage unfolds. In Washington, D.C., engineers meet under blackout curtains in the War Production Board. Blueprints are unrolled across long oak tables. Each drawing is duplicated, microfilmed, and stored in a vault in Chicago. If one city burns, another can pick up production without hesitation. In Detroit, factory managers are briefed on emergency dispersal. Duplicate dies, molds, and master tools shipped to sister plants in Illinois and Wisconsin. The idea is mechanical. If one gear jams, the others must keep the system turning. The Germans knew the targets. Luftwaffe aerial reconnaissance units photographed Wright Aeronautical, Curtiss-Wright, and Packard Motor Works. They identified foundries, rail yards, and chemical plants feeding the aviation fuel supply. Reports circulated through the Oberkommando der Wehrmacht that destroying even two of these complexes could delay aircraft production by 6 months. Albert Speer repeated that line in conferences, pointing at figures showing German industry's own fragility after Essen. He assumed the Americans would break in the same way. But the Americans had already prepared for such blows. In 1942, even before the heaviest raids began, the Army Corps of Engineers developed rapid recovery protocols. Every major plant was mapped with redundancy plans, backup power grids, spare machine tools stored in regional warehouses, and construction battalions trained to rebuild on site. This was not improvisation, it was doctrine. Cryptographers at Bletchley Park and Arlington Hall added another layer. They intercepted Luftwaffe communications that spoke of decisive strikes against American production. By early 1943, the Allies knew the Germans expected long delays in recovery. That intelligence filtered back to U.S. planners, who took it almost as a challenge. Instead of months, they would measure recovery in weeks. The montage ends with 2 images split screen. German officers in Berlin, marking American factories with red X's on reconnaissance maps, and in Dayton, American welders sliding new beams into place under floodlights, sparks falling like rain. Both sides believed they understood the stakes. Only one was right. Searchlights stab into the night over Pennsylvania's factory belt. Their beams sweep across the clouds, crisscrossing like the blades of rotating turbines. Along the riverbanks, anti-aircraft batteries stand ready, 90mm M1 guns loaded with timed shells, elevation gears clicking as they track unseen bombers. Operators grip headphones, listening to radar chatter piped in from the new SCR-268 sets that pulse invisible waves across the sky. Each flash of contact is plotted on grease pencils over glowing boards. The factory complex itself glows faintly, blackout curtains masking its heart while furnaces roar inside. The defenses are layered like armor plating. Overhead, patrols of P-47 Thunderbolts circle on long sweeps, their Pratt & Whitney R-2800 engines thrumming like piston hearts in the dark. The fighters are short on range but vicious in firepower. 850 caliber Brownings mounted in each wing, the aerial equivalent of a belt-fed firewall. On the ground, fire trucks and engineering crews stand by as though this were a forward base, not an American town. Every component is treated as military hardware because, in 1943, it is. Inside, production lines resemble arsenals more than factories. Wright Aeronautical's shop floor is lined with crankshaft forges capable of pressing 12,000 tons of pressure per strike. Overhead conveyors carry pistons and connecting rods, each tagged for assembly into radial engines destined for B-24 Liberators. The scale is immense. In a single week, the plant can complete 1-200 aircraft engines when running at full tilt. Supporting materials flow in with similar rhythm. 27,000 tons of steel rerouted weekly through Pennsylvania rail corridors to replace what raids destroyed. Every figure is weaponized. A single B-24 requires 13,000 rivets, 600,000 parts, and more than 450,000 man-hours of labor. The American loadout is not just the bomber in the air, but the factory that breathes it into existence. When one machine tool breaks under stress, another is rolled out from storage. When a conveyor seizes, prefabricated spares are lifted in by crane. The system is designed not just to produce but to absorb shock, like a suspension built to keep rolling even when one spring snaps. German intelligence reports captured after the war confirmed that Luftwaffe officers underestimated this capacity. They logged raw figures of destroyed square footage, but never accounted for the layers of redundancy built into the American arsenal. In Berlin, charts showed acres of factories blacked out. In reality, those acres concealed machine halls still humming, guarded by guns, radars, and men who treated a production line like a battlefield trench. The loadout snapshot is clear. America's industrial front line was armed, armored, and, most importantly, replaceable. The night sky over the Allegheny Mountains is alive with sound, propellers droning low, engines straining under the weight of bombs. German long-range aircraft, Heinkel, He-177s modified for deep strikes, push through cloud banks toward Pennsylvania's industrial belt. Their silhouettes are faint against the stars, but their intention is unmistakable. On the ground, sirens howl. Factory whistles shriek as workers glance up at the ceiling waiting for orders, but not all leave. In Dayton, in Pittsburgh, in Cleveland, men and women stay by their machines. Blackout curtains are drawn tight. The only light the orange glow from furnaces that cannot be extinguished. Molten steel still pours into molds as spotters outside scramble onto rooftops with binoculars. To halt production would be to grant the enemy what he came for. Searchlights snap on. Beams rake the clouds in jagged arcs. Anti-aircraft batteries thunder, the concussions rolling across the valley like steel hammers. The 90mm M1 guns bark in timed rhythm, shells bursting above, scattering shrapnel fields across the approach routes. Operators adjust dials on their SCR-268 radars, calling bearings into field phones. Every movement is precise, mechanical, like gears meshing inside a gearbox. The first bombs fall. Explosions ripple across a rail yard, boxcars bursting into flame, the tracks twisted and smoking. A second wave punches into the roof of a machine hall, glass shattering, overhead cranes collapsing in sparks. The ground shakes, dust plumes rising through broken skylights. Yet inside, amid the smoke, presses continue to hammer steel. Workers cover their mouths with cloth and keep loading billets. Supervisors shout over the din, "Keep the line running!" American fighters scramble. P-47s roar into the night, climbing hard to intercept. Their engines bellow as tracer fire cuts across the dark sky. One Heinkel is hit, its port engine trailing flame, breaking formation before diving into the hills. Others press forward, dropping payloads blind through cloud. The defenders are stretched thin, but the factories refuse silence. In the immediate aftermath, craters pockmark the ground, rails glow red from heat, and debris litters assembly sheds. But even as the all-clear sounds, trucks roll in carrying spare girders. Emergency crews swarm the damage. Smoke is still rising when welding torches spark again. To the attackers, it looks like devastation. To those inside, it is interruption, nothing more. This first contact makes the pattern visible. Bombs could wound, but they could not halt. America's factories absorbed the strike and kept their pistons moving. For the German crews returning across the Atlantic, the photographs promised more destruction than reality ever delivered. The smoke from the first raid still lingers when the adjustments begin. American planners move like mechanics tightening bolts after a stress test. In Washington, new orders go out. Duplicate every critical production line. If Detroit is hit, Illinois must cover the quota. If Dayton is damaged, Wisconsin steps in. Within weeks, factories in 3 states are retooled to mirror one another, down to the precise spacing of lathes on the shop floor. The industrial grid becomes less a series of buildings and more a network of interchangeable parts. On the ground, radar nets are thickened. The early SCR-268 sets that tracked aircraft at short ranges are paired with the newer SCR-270 long-range radars, extending the warning time from minutes to nearly an hour. Signals flow into command posts, where plotters move markers across maps with practiced hands. The system functions like an electrical circuit. If one node is cut, current flows through another. Convoys are rerouted as well. Raw materials bound for Ohio are shifted onto secondary rail lines that curve through less targeted towns. Locomotives run under armed guard, headlights dimmed, timetables shuffled daily to confuse enemy intelligence. In 1 month alone, the War Production Board diverts over 50,000 tons of steel through alternate corridors, ensuring that furnaces never cool. Air cover evolves in tandem. The P-47s that once patrolled short arcs are joined by newly arriving P-51 Mustangs, their drop tanks giving them reach across entire states. These fighters orbit above the industrial belt in rotating shifts, a constant presence that forces German bombers higher, where accuracy dwindles and fuel runs thin. Reports from surviving Heinkel crews note tighter defenses and longer interception times, their missions stretched to breaking point. The factories themselves shift posture. Managers implement hot spares, duplicate machine tools bolted down in adjacent halls, ready to be powered up the instant a line is damaged. Warehouses stockpile prefabricated steel beams, concrete slabs, and electrical cabling, all labeled and staged for immediate use. It is an industrial version of rapid reloading, like swapping a magazine into a weapon without losing cadence. From Berlin, German officers review fresh reconnaissance and are unsettled. The bomb damage is visible, yes, roofs torn open, rail cars burnt. But within days, activity resumes. Rail sidings are cleared. Smoke from new chimneys blurs the camera lenses. In one report, a Luftwaffe analyst remarks bitterly, "Ihr Schlag verzögert sie nur, stoppt sie nicht." Translation, "Your blow only delays them. It does not stop them." The countermove is not just military, it is systemic. Every German adjustment meets an American counter-adjustment. Each raid becomes less decisive, more costly, less sustainable. The Reich had gambled on American fragility. Instead, it faced resilience designed into the blueprints. The clang of steel never stops. Inside the machine halls, the air is heavy with the stench of oil, sweat, and ozone from welding arcs. Shifts stretch from 8 hours to 14, then to 16. Men slump over benches during brief breaks, their faces gray with exhaustion. Women in coveralls, many newly trained, work stamping presses until their hands blister, then wrap them in rags and return to their posts. The war economy runs like an overheated engine, efficient but pushed near the red line. Technical strain shows itself in hard numbers. Reports from the War Production Board in late 1943 note warped steel forgings caused by rushing billets through furnaces too quickly. Turbine blades sometimes crack under stress tests, failures traced back to exhausted workers skipping inspections. Bearings are rejected by quality control at higher rates, up to 7% in some batches, because precision cannot be rushed forever. Each defect represents not just wasted material, but hours lost. Even the defenses creak. Radar operators complain of blind spots where mountainous terrain cuts signal returns. Fighter squadrons struggle to maintain constant patrols, aircraft grounded by weather or simple mechanical fatigue. Every machine, from the B-24 bomber to the stamping press, has limits. And when those limits are pressed too hard, breakdowns follow. Fatigue is recorded in diaries as well. A young welder in Cleveland, Margaret Lewis, writes on October 11, 1943, "The factory shakes all night from hammering. I sometimes forget the difference between thunder and presses. We work until our eyes water and our ears ring. They say the men flying overseas depend on us. I only hope these hands can keep up." Her words echo the human cost beneath the tonnage charts. Managers warn Washington that pushing harder risks collapse. Skilled welders are scarce. Training programs struggle to keep pace with attrition, and materials like nickel and chromium grow tight under global demand. The supply chain creaks like a stressed girder, bending but not yet snapping. The German High Command studies these weak points with interest. If they can time raids to hit during peak strain, perhaps recovery will finally lag. But for now, despite fatigue, the pistons keep firing. America's machine groans under the load but refuses to stall. The raid comes on a cold night in November 1942. Curtis Wright's massive engine plant, a facility responsible for churning out power plants for fighters and bombers alike, lies directly in the bombers' crosshairs. The first wave punches holes through the roof. Incendiaries tumble inside, setting machine oil alight. Flames crawl along the floor like liquid fire. Overhead cranes crash down in sparks, smashing half-finished crankshafts beneath twisted steel. For the first time, production stops. The damage reports are stark. More than 30% of the plant's machine tools are destroyed or disabled. Assembly lines are severed. The power grid feeding the complex is knocked offline for 2 days. Army Air Force's supply officers warn that at least 200 aircraft deliveries will be delayed, a figure that reverberates through Washington with alarm. For a brief window, it looks like German strategy has struck gold. Propaganda ministers in Berlin seize on the news. Newspapers trumpet headlines that American industry is crippled, that the so-called arsenal of democracy has shown its fragility. Radio broadcasts boast of victory, claiming that thousands of Allied airmen will soon be grounded for lack of engines. The Reich's own industrial officers whisper that perhaps the tide can be turned not on the battlefield, but in the workshops. On the ground in Ohio, the scene is grim. Smoke lingers in the rafters. Workers sweep debris under a haze of ash, coughing as they dig out the wreckage. The silence of stopped presses feels heavier than any bomb. For the first time since the raids began, the American machine has stalled, its pistons frozen mid-stroke. Military records confirm the seriousness. Deliveries falter, schedules slip, and for several weeks, frontline units wait longer for replacement aircraft. In Italy and North Africa, pilots curse the shortages. Commanders tally numbers and wonder if the vaunted American supply lines might finally buckle. For the Germans, this is validation. Their arithmetic, their models, their assumptions, here at last is proof. A single raid, properly aimed, has delayed thousands of tons of output. To Berlin, the weakness seems revealed. What they cannot see, not yet, is the improvisation already beginning in the shadows of the wreckage. The wreckage at Curtiss Wright still smolders when the countermeasures begin. Army Corps of Engineers trucks arrive before the fires are even cold, headlights cutting through the smoke. Teams of construction battalions pour into the plant, hard hats and uniforms mingling in a blur of urgency. They move with precision, like mechanics swapping broken pistons from an engine under combat fire. Prefabricated steel beams are rolled in from warehouses on the city's outskirts. Each section is labeled, numbered, and designed for rapid assembly. Cranes swing them into place as if erecting a field bridge. Replacement generators, shipped from reserve depots in Indiana, are wired into the gutted power grid within 48 hours. Floodlights blaze, illuminating the work through the night. The factory, only days earlier written off as crippled, hums with the sound of cutting torches and hammer drills. Workforce improvisation matches the engineering. With skilled welders in short supply, women from neighboring training schools are rushed onto the line. Some are handed assignments after only a week of crash courses, guided by supervisors who walk them through the motions step by step. They burn their first seams with shaky hands, but by dawn they are welding support strong enough to carry the rebuilt roof. The war does not allow time for perfection. It demands function. Meanwhile, production managers cannibalize. Spare machine tools mothballed in warehouses are dragged out and installed in any surviving bays. Assembly sheds untouched by fire are rearranged. Engines pieced together in improvised spaces. Even church halls and high school gyms are requisitioned as temporary workshops for subcomponents. Every square foot becomes part of the recovery grid. The speed shocks even the Americans themselves. Within 2 weeks, the crippled plant is operating at 60% capacity. By the end of the 6th week, it surpasses its pre-raid output, churning engines faster than before. The accident forces improvements, workflows streamlined, inefficiencies stripped out, bottlenecks bypassed. What began as a blow becomes a catalyst. Berlin notices too late. Reconnaissance photos expected to reveal silent ruins instead show new roof sections gleaming under the sun. Rail sidings are again packed with boxcars. Smoke climbs from chimneys in steady streams. The German expectation of paralysis has been shattered by improvisation. The lesson is mechanical and brutal. An engine forced to run hot may seize. But strip it down, rebuild it under pressure, and sometimes it runs faster than ever. America's factories prove the same rule. The summer of 1944 brings the breaking point. From Berlin conference tables to forward airfields in France, German officers track intelligence reports with growing disbelief. Figures scrawled in briefing books tell a story that no amount of optimism can disguise. By June, despite 2 years of bombing raids, America is producing nearly 8,000 aircraft per month. Engine shipments exceed 200,000 units in a single year. The Reich's own factories, under ceaseless Allied bombardment, limp along at half that pace. On the front lines, the evidence is undeniable. Luftwaffe fighter pilots climb into the sky expecting dwindling enemy numbers. Instead, they face endless waves of Mustangs and Thunderbolts. Each destroyed bomber seems instantly replaced by 2 more. Crews whisper in disbelief. It's as if their assembly lines never sleep. The reality is harsher. The lines not only recover, they accelerate. At a staff meeting in July, Luftwaffe General Adolf Galland reportedly snaps, slamming his hand against the table. "It is madness," he mutters, as cited in the Reich Air Ministry's minutes. He points to the graphs of output climbing despite the bombing. His staff shift uncomfortably. The room smells of tobacco smoke and sweat, the air heavy with the knowledge that their campaign has failed. The U.S. system proves unstoppable because it is not a single factory but a network, redundant, decentralized, and coordinated. Destroy one plant in Buffalo and 3 in Detroit, Chicago, and Cleveland surge forward to compensate. Railroads and highways bind them into one organism, parts shuttled across thousands of miles as if along arteries. The Germans had imagined a body vulnerable to a single strike at the heart. What they encountered was a machine built from countless gears, each capable of taking the load when another failed. On the production floors, the sound is deafening. Stamping presses thunder like artillery, furnaces roar, conveyor belts rattle with parts moving from station to station. Workers, driven by shifts that run day and night, operate with an urgency born of sons and brothers fighting overseas. A diary entry from machinist Clara Rollins, dated August 2, 1944, reads, "We heard the Buffalo plant was hit. The next day, we worked double. It felt like every rivet we drove was revenge." For German officers, the climax is not one moment, but a tide that crests all at once. Reports converge. Replacement bombers arriving in England faster than losses, armored divisions supplied with new tanks at a rate impossible to match, convoys across the Atlantic swelling rather than shrinking. The statistics are merciless. By late 1944, the United States produces 96,000 aircraft in a single year, while Germany struggles to reach half. The arithmetic of war tilts beyond recovery. The realization lands with the finality of a hammer strike. Bombing America's factories has not crippled them. It has hardened them. The Reich's industrial strategy lies in ruins buried beneath the avalanche of American output. The war's last year leaves no room for illusions. Germany's industrial gamble, cripple America at the source, has collapsed under the sheer scale of U.S. recovery. By 1945, official War Production Board records show that more than 2.1 million aircraft engines, 86,000 tanks, and over 41 billion rounds of ammunition have been manufactured since America's entry into the war. These numbers are not abstract. They translate directly into fleets of bombers over Berlin, divisions of armor in France, and ammunition stockpiles so vast they outpace consumption. On the German side, the story is the inverse. The Reich's factories remain under constant Allied attack, forced into underground caverns or dispersed sheds. Production continues, but at a crawl. Reports to the high command are laced with despair. Shortages of fuel, shortages of skilled labor, shortages of everything except defeat. What began as a strategy of offensive raids against U.S. industry ends as a lesson in futility. The aftermath is visible in the ruins of Europe. American convoys steam into Cherbourg, Antwerp, and Marseille, unloading tanks and trucks as fast as cranes can lift them. New aircraft land daily on freshly built airfields in Normandy. Factories in Detroit and Cleveland, once targeted by German planners, run at higher capacity in 1945 than they did in 1942. The Luftwaffe, bled white in the skies, no longer has the pilots or machines to contest them. Captured German officers voice their astonishment in interrogation reports. Colonel Ernst Manke, taken in April 1945, admitted, "We did not believe a nation could replace bombed plants so quickly. For every target struck, 3 more seemed to rise in its place." His words capture the realization spreading across the defeated officer corps. The industrial war had been lost long before the front lines collapsed. In the final accounting, the United States turned destruction into acceleration. Each raid became a trigger for faster output, each setback a reason to adapt. The machine kept running, rebuilt stronger each time a gear was stripped away. The lesson of those years is carved into the statistics of production and the silence of ruined Luftwaffe airfields. America's factories, bombed but never broken, proved that resilience in steel and sweat can outlast even the fiercest assault. The thesis is stark. In the clash between destruction and reconstruction, speed of recovery decided the war, and America's factories outran the bombs.